Problem 5. Janet rolls a standard 6-sided die 4 times and keeps a running total of the number she rolls. What is the probability that at some point her running total will be equal to 3? Well, this is just simply casework, right? Okay, so let's start from the beginning. She has a 6-sided die numbered 1 to 6, obviously, and we rolled that 4 times. And we want that the summation of all the cumulative values to be equal to 3. Well, obviously, if we roll it 4 times, what is the minimum of each roll? The minimum of each roll is 1. So the minimum we can get after rolling it 4 times will be 4, which obviously exceeds 3. So therefore, what does this mean? This means that we can only get 3 after 3 rolls, because we get 4 rolls that will always exceed 3. So therefore, we have 3 cases. Case 1, Case 2, Case 3. Case 1, it took 1 roll. Case 2, it took 2 rolls. Case 3, it took 3 rolls. Let's start with Case 1, where it took 1 roll to get a total of 3. Well, how many total probabilities do we have? How many combinations? Well, we have 6, because we have 6 total numbers to potentially get. 1, 2, 3, 4, 5, 6. But what is the one desired number? It's 3, which is one of the 6 cases. Therefore, the probability of getting a 3 on the first roll will be 1 over 6. So that is our first case. What about our second case? It took us 2 rolls. So now we have roll 1 multiplied by roll 2. We multiply because this is an AND relationship. We must get roll 1 and roll 2. Let's see roll 1. For roll 1, we have 2 possible ways. 3 is equal to 1 plus 2. 3 is also equal to 2 plus 1. So on the first roll, we can get a 1, then a 2, or a 2, then a 1. So let's start with this case, where the first roll gets us a 1. Well, obviously that's 1 over 6. But then after we roll it, what is the probability that we get a 2 on the second one? Well, the second roll is independent of the first one, so that's 1 over 6 as well. Because we have 6 possible numbers, we want a 2, which is one of the 6 solutions. So this is equal to 1 over 36. That is for this case. What about for the second subcase, when we get a 2 on the first roll and 1 on the second roll? Well, that's going to be the exact same thing as 1/6 squared. So multiply by 2 to get 2 over 36. Now, I leave it as this for now, and you will see why later on. But basically, that is the solution for case 2. What about case 3? Well, that's the same thing. 3 is equal to 1 plus 1 plus 1. So that means that we must roll a 1 on all 3 rolls, so that's 1 over 6 to the third. Right? And it doesn't matter if we get this one to be first or this one to be third, because they're all the same number. So there's no like combination or arrangement. So 1 over 6 to the 3 will be your answer for case 3. And we have all 3 cases founded. So all we have to do is sum up the cases. We sum up cases and we multiply AND relationships. So that's 1 over 6 plus 2 over 6 squared plus 1 over 6 to the cubed. That is the same thing as 6 cubed. In the numerator, that would be 6 squared plus 2 times 6 plus 1, which is the same thing as 36 plus 13 over 6 to the third, which is equal to 49 over 6 to the third. Now, obviously, 49 is the only choice in choice B that has a numerator 49, so your final answer must be B, and 6 to the third is obviously 216.